Hello everyone, so in this video we're going to be talking about writing testable code and writing tests for that code. These should be ideas that are taken together and worked in partnership, but oftentimes these are for some reason split up. They're always considered in two parts, and that's usually due to a lack of understanding of test and development as a whole. The code that you write is not going to be testable unless it is written in a manner that makes it testable. And there's a lot of things to consider here to make your code testable. And when we say testable, we mean easily. We don't want to make it a burden to write the test for our code. We don't want to have to create a multitude of mocks using different libraries like Mockito, but also Power Mockito and others just to get across the tests for our classes. There are a lot of ways that your code will be difficult to test, but there's also very clean, easily digestible, and maintainable ways to create your code so that it's also easy to test. And tests themselves have a very specific purpose to make sure that your code works the way that you expect to in all ways that you can expect and think of on your own. Now, you can have a notion of code coverage, which is how many lines of your class are actually executed in your tests, and how many of those lines are executed in tests that pass. So if a test fails, we're going to mark that as well in the code coverage that this line is executed in a failed test. Hopefully you're not deploying any code when tests fail. That's a whole other discussion, but you shouldn't do that. But with the code coverage, there's a very large discussion to be had there that we will open up a little bit later on in this video. So let's get to just the clean code for our class here. We're looking at an employee class, very simple, and we're just going to focus on the aspect of an employee for calculating pay. Now, there's oftentimes just two categories of employees. You have an hourly employee or a salaried employee. So that's something else that we're going to put a big emphasis on and figuring out how to calculate that. So let's start from the top and work our way down. You'll notice, like in many of the videos so far, we're using a Lombok builder here so that we don't have to define the constructor and the logic there, making the code a little bit shorter and easier for us to read. And then you're going to notice we have two constants to start off, an overtime modifier and a full-time hours constant. The modifier is 1.5, which is just going to be used for calculating the value of overtime hours for hourly employees, meaning if they work more than full time, the rest of that pay is multiplied by 1.5. The full-time hours is the constant we're going to use to compare the hours worked to appropriate full-time hours. Next, we'll just see our two attributes for creating an employee class. Is hourly and base pay a boolean and a double respectively. Is hourly will be true if the employee is an hourly paid worker, and it'll be false if they're salaried. Base pay will be the hours that the employee works, or the money given per hour an employee works if they're an hourly employee, or the salary for an employee during that pay period. Calculate pay is going to be our only public method, which actually returns to the consumer of this class what the pay is for a particular employee, given the hours that they worked that week. You'll see that we just check to see if they are an hourly employee, and if so, we calculate hourly pay. Otherwise, we return base pay. Next, we have the actual calculate hourly pay, which will find the overtime hours. And if there are overtime hours, it'll calculate using our overtime modifier, the base pay, etc. And then last, we have the method that actually gets the hours that we worked overtime, which is, of course, going to be hours worked this week minus full-time hours. Now, we're going to talk about the tests briefly after this, but I first want to mention there are bugs in this code. Very deliberately, there are bugs in this code. Let's close this project over here. So we're going to discover those bugs through tests and talk about the bugs that aren't found in the tests and why, to kind of discuss the importance of code coverage and also the blind spots of code coverage. That even if all of your lines are covered, there's still bugs that you can find in your code that may have real world implications, even though you have 100% branch and line coverage in your code. So there's at least two that you can see just by looking at the code and ignoring the logic. But again, we'll get to those briefly. This is the class we're going to test, and this is kind of the code that we're going to be focusing on for the main portion of this. So if we go over to employee test, you'll see that this class is first off way larger. In fact, I actually have to make some new lines to even get it within the recording screen. This class is a test class. All of them should always be denoted with the name of the class that they are testing, employee, and appended with the word test. JUnit requires that you do that. Some other testing frameworks may not. We're not going to go into test frameworks specifically and alternatives to JUnit or anything like that. JUnit's used everywhere, so you might as well use it, but there are other ones. But really, find one that you like and work with that. But as far as a convention standard, you should always have the name of your test class be the class it's actually testing, in this case employee, and appended with the word test so that you can see that. It should also be in a separate test folder rather than in the source folder, and it should be in a package that follows the same package scheme as the source class. Now, when we look at this next, well, actually first, let's go back. We have 57 lines of code here, or 56 lines of code here. If we go to employee, we only have, 32, 31 lines of code. So we're talking about almost double the amount of codes just for the test here. Why is that, and is that appropriate? It's actually very much expected that your tests are larger than the code that they're testing. If they're not, then you're either talking about a very, very simplistic class, probably even one that's just a constructor and nothing else, or you're talking about a class that doesn't have proper coverage and isn't being tested according to how it should be. So you'll see we only have one public method, and each one of these tests actually calls that public method. It's going to be the calculate pay method. But we don't have just one method. We have four. That's because there's four general cases that we want to cover and check the values of. But before we get into logic there, let's talk about these constants up top. We have a lot of them, right? We have a salary employee base pay, an hourly employee base pay, a full-time, a overtime, a hourly employee full-time pay, and an hourly employee overtime pay. All these constants are going to be used in our tests, and they should always be named so obviously that by reading it you get the context. There shouldn't be anything here where we're confused. At most, the only thing I can really see is that maybe we should say full-time hours, or weekly full-time hours, or weekly overtime hours. That's something that would make sense and could be useful. In fact, let's actually rename this one overtime hours, because we're probably going to use overtime in a variable name. So let's change these to have hours after them. You want to make these as obvious as possible because you may not be the next person reading this, and you don't want to have to take on the task of explaining someone your bad code later on when someone's touching this class again. And that will always happen. You can't help but have someone eventually work on the code that you've written before, and you want to make it so obvious that they can individually work without having to ask you, hey, what is this? Why does it work this way? And why did you write something so confusing? But the others are very obvious. We have a base pay, which is the hourly pay, and we have a salary. We also have the calculations for the full-time employees' pay if they work just the full-time hours or if they work the overtime hours. If you take a brief moment to pause and look at these values, though, we have actually duplicated some logic. And let's talk about why that is. Specifically, full-time hours here as 40 is also defined here, although there's a typo that I just now noticed, so let's fix that. This value is duplicated. We have it both in the source code class that we're testing, as well as in the test class itself. This isn't great. You might see this quite a bit, and it's due to some standards that people will have, but it's not something that we want. We don't want to duplicate code between our tests and our source as much as possible because it's prone to errors and it leads to issues in the future where maybe legislation changes and full-time hours are now 35 hours. It's not 40 hours a week, it's 35 hours a week. If you change it here, all of your tests will fail. And that is the one thing that holds this up right now. That we expect the test to fail if this value changes in the source code. And that's great. That's expected, and that means that our tests are actually testing our code. If something like that is true, your source code changes, it should always break your unit tests. If your source code changes and it doesn't break your unit tests, your tests are not specific enough and detailed enough for your source to have proper code coverage. Now, if we go back over here, how can we get rid of this? There's a couple ways. The two most popular, if this is an issue that you want to change, is that there's an annotation for some libraries called visible for testing that you can put on a value like private static final ints or any kind of constant, and it'll allow your test package to view that variable. Although that breaks a lot of expectations you'd have of your code and can just lead to some other issues in the future. The other option is to make a separate class, something named employee constants, which holds that value publicly rather than privately, so that anyone who needs constants for an employee can pull them from there. And that would then make it accessible to both the source code class that needs it, being employee.java, and it would also be available to the test code employee-test.java. That's pretty trivial. I'll leave that up to you to decide which of those you want to go to and which one you would like to use. But keep in mind that that is an issue. On the other side of the coin, if we change the value in the test, it will also break the unit tests. If we change this from 40 to 45, we should still see an issue because the source code will no longer give a value that matches what we calculate in the test code. So as long as you hold some sort of requirement like that in your tests in your source code, it should prevent you from having any catastrophic failures, though it's still not ideal and it's something that you'll want to discuss with your team if you don't already have standards on this, how to address that in the future, because this isn't an ideal situation and it shouldn't be something that is just left out and left as is in your code base, because eventually you'll run into issues where someone does this and it doesn't impact both sides of the test and the source code. All right, moving on. Let's get to the actual tests here. These are all pretty simple. They're going to all begin very similarly. They're going to have a employee class that's built, and then they're going to assert that when they call calculate pay, that we get the expected value. You'll also notice the name of the functions that we're using to test have a similar pattern. The first half is going to be test, followed by the method that they're actually testing. In this case is calculate pay because it's the only public method. And then it's going to have an underscore, followed by the specific condition that we're testing, which in this case is we're testing a salaried employee, and we're doing that under full-time constraints for the hours worked that week. You'll also see down here we have hourly employee full-time, hourly employee overtime, and we even have a salary employee overtime, which we will talk about why this specifically is important in just a bit. But these tests are all pretty simple. We take the base pay that we expect, or even the calculation for full-time pay that we expect, and we compare it to our calculate pay output. Now, one thing that you may notice is we have this assert equals method everywhere. This is a method that comes from JUnit as well, and it will either fail the test or pass the test, or it'll either fail the test or move on executing, which will eventually have the test pass, based on if that's true. So if we say assert equals, if the values passed to this method are not equal to each other, it will fail the test. You can also fail a test manually if you need to do some other fancier things that aren't available to you through JUnit by default, by actually calling a method called fail, which is a part of the same class assert. So let's run these. Let's see what happens. Let's see if they all pass. We already know that they won't. As discussed, we do have bugs, and at least one of them should be caught here pretty quickly. But let's see what happens first. So we see some warnings. If you have a quick glance over them, none of them are too worrying for what we're doing. In fact, it's because of kind of the settings I have for this project are a little messed up. But oh, hey, here we go. We have some tests executed, and we'll see with these check marks that these two pass, but these two fail. Why is that? Well, uh, one of them fails because it's actually wrong, and the other one fails because of a very small, strange issue in the code that we have for this assert equals. So let's first go to the full time and let's figure out what's going on here. So if we say calculate pay full time hours, we should see some value of employee full time pay, hourly employee full time pay. And let's just go up to the top real quick and see what we define that as. It's full time hours times employee base pay. All right, so that's about 906 and 80 cents. You can check that, but that's what we're looking at. We got 22.67. So let's ignore the issue of this huge long tail of numbers followed by a 1. Why did we get 22.67? That's off enough to where it should ring some bells that something is drastically wrong. Whereas if we look at overtime pay, we get something similar that is scary, right? Like now we're seeing a number that's even larger, and we're still seeing this 22.67. So what's going on? Something is wrong. Well, let's go back over to employee. When you see an issue like that, you need to start at the method that you're calling and see if there's anything obvious. In this case, there is. We're not returning the value from calculate hourly pay. We're just calculating that hourly pay and then not returning it. We just return the base pay. So we always get the hour back. You can see that in the test we had a constant value returned of just the hourly pay and nothing else. So we know that there was some sort of condition that wasn't being met because we were consistently getting the same value. It wasn't a calculation being wrong because the output we got was the same. If the outputs were different, then maybe we have a calculation issue in calculating hourly pay, and that's something else we could check. Now in this case, there's a couple ways that you can handle this. You can either return calculate pay here and then leave it, or you can go a step further and say else and cover base pay there. The second option I like more, and the reason for that is that if we had wrapped this in an else statement first, then we would have gotten a syntax error when we get rid of that return statement, because now there's even though we're supposed to calculate a value here, we don't return, or we're supposed to return a value here, we only return it in this else case. We don't return it everywhere, and that is a problem. And you'll see it right here on this brace. It's going to say, hey, you're missing a return statement. So now we have a syntax error that makes sure that we prevent that bug. So I tend to always do if else's if I'm returning in those values. The other option is that you always return at the bottom. I had a professor that always always said that this is how you should do it, but I think that's still debatable if he was right or just particularly opinionated. But we can make another value that holds the calculated value as we move on. So in either case, we have our calculate pay equals base pay, or if it's hourly, calculate pay equals calculator pay. And that way we're always returning something. This will also require that something is returned and give you a syntax issue if there isn't, because it'll say, hey, this value may have never been assigned. The issue with it, though, comes down to readability. Maybe your team doesn't like this, and it's something they don't like. Like I said earlier, I had a professor in college who said that this was the way to go because it made things more readable and it made things easier to actually formally prove mathematically, especially for iterators. It made it a lot easier to do mathematical induction, but that's a very big tangent and we're not going to get into that here. So this way you can still force that you have a syntax error if you're not actually using the value that you're calculating. So if we go back here, We're still going to get some errors, but we can run this and see if we have a better idea of what's going on. All right. So, oh, hey, it didn't fail that time. So I guess that may have actually fixed all of our issues. What I was going to mention before is that we're using a double for these values, and because of that, when you run this, it's going to do a calculation on doubles for most of these. The salary employee will always pass because it's just a static value that doesn't have any calculations. But for the hourly employee where we're calculating things, you can have rounding issues, and that's where you would want to use this delta, which allows you to adjust for those errors. But it looks like now that we are returning things appropriately, that drift is happening in two places, which is something that is still a bug, but it's not caught by the test. I thought that one of the tests would still catch it, but like I said, it is still a bug, and I'm going to show you how to find that. If we, before we do that though, if you go back up to the top here, and instead of running your test, you say run with coverage, this will give us some interesting information when we look at the employee class. So you'll see these green bars here. That says, hey, this code is covered by the tests, right? Um, but what you'll notice is that everything we're really interested in is covered here, right? There is some code that's not covered because we don't test some constructors, like the default constructor is still available, which we don't execute. So you can have some method missing and some lines missing there. But you see that all the calculations are called, right? We do use this else statement. We do use the if statement. We of course return stuff. All that's happening. We do check the overtime. We do return without overtime, and we do calculate using this line for the get overtime hours. But we still have that bug, right? Because the first time we ran this, we noticed that there was additional error in our double value when we had those calculations. So if we go over here and where is let's do the full time, for example. If we set up a debugger here on this line, or not even on this line, my bad, let's go back to employee. If we set up a debug line here, once we get here, it's going to stop, and we're going to be able to inspect the values that we have. So let's go back to test. Let's go here and say that we want to debug. Now, when we get to this step, you'll see that we have calculated pay of 906.8, a lot of zeros and a 1. That's a bug. If you tell someone, hey, your hourly rate has 2 decimal places, but we're going to pay you to like 15 decimal places, that's going to raise some eyebrows, right? Like something's clearly wrong here. Why is that? What's going on? This is because of a calculation issue with the doubles. And this is something that a lot of textbooks will talk about when you're learning a language, that doubles have more precision. But because of that precision, there is often a precision error in this. The best way to get around this is to actually encapsulate the logic somewhere else. We're talking about money here specifically. We should be using a money class that handles these rounding issues and checks it. But what we need to do here is check, not that, we want to make sure that this value is returning something appropriate to 2 decimal places, but none of our tests check that. So why is it that none of our tests figure out that this is an issue, and how can we make it so that they do? There's a couple ways that we can make our test methods cover that case, right? All the code is being executed appropriately in these tests, but we're still having an issue due to that variability in the double calculation. There's a couple ways of doing it. One is that in the overtime pay, we just set it to a static number, my bad, we're using full time in this case. So in the full time, you just actually statically assign that value, and then you'll catch that the double doesn't match exactly. And you can do the same thing here in the overtime pay. That's one way of doing it. The other one would be to go into your source class and actually handle the rounding itself. In that case, you would actually see the failure because the test would be incorrectly calculating the double without the rounding and the truncation of those decimal points. And the solution to that is, again, left up to you. But that's a case where we have tests that uh, everything passes, but they fail. They would actually fail in the real world. If you told someone on their paycheck that they got $906 and 80 cents and 1 billionth of a cent, that's an error. That's wrong. So these are things that you have to keep in mind. Even though we have test coverage on the lines that calculate pay everywhere, we're still running into an issue where we very, very much have a problem. And it's in our source code. Also, it's in the test code. Now, what about the rest of this? Is there anything else that we could do better here? Yeah, there are. There's a few ways that we can make this better. One, calculations like this should be moved into their own method. And the reason for that is that we don't want to have large calculations in conditionals like this because it means that each method is holding kind of a burden that another method should hold for it. We only want our methods to have one single responsibility, and in this case, it should be determining how the hourly pay is calculated. And if it has to then go into a further calculation, then it should be sent to another method for that calculation. The lower level things get, the more often you'll probably see things doing less and less. Whereas in the broader scope, like the public methods, you'll see more. That's something that is also stylistically up to your team, but the standard rule should be that if something is more publicly accessible, the single responsibility that that method has should be nailed down. So don't look just at the number of lines of code, but look at the responsibilities that function carries. In this case, simply calculating the hours by multiplying with a class attribute versus an actual multi-step calculation that is for a specific case. And as we said above, we should also be wrapping this in an else statement rather than in by itself, so that we can make sure that we're always returning the appropriate value. And that's something that you would test in any of the cases that exist now for the tests, but that's something that you should be aware of in the future, because there are easy ways to make sure that you avoid those errors and that your code won't even compile if you write your code well enough, and you'll prevent those bugs from happening. So yeah, that is all that I have for you today. If you have any questions or comments, anything that you believe was missed or wrong, leave it in the comment section below, and we'll have a discussion about it. If you like the video, hit the like button, and if you want to stay around for the future videos in the series, hit that subscribe button. Thank you.